Okay, so the quadratic formula is a way of solving for the x-intercepts of an equation. X-intercepts also called zeros because the y-coordinate is 0, or sometimes known as roots. So the quadratic formula is a way of solving, it's another way other than factoring. When factoring is relatively straightforward, it's easier than the quadratic formula that I'm writing out here. But not everything can be factored. And in fact, sometimes the quadratic formula will yield no real solutions. We'll talk about that at a later date. But what I'm going to show you here is how to develop this formula by completing the square on the standard form equation to get it into x equals form. Okay. Now, you will not be expected to do this every time. You're just going to be expected to use the formula. But here's how the formula was first developed a few thousand years ago. So, my first step in completing the square is to move the constant. Well, the constant here is c to the other side, giving me y minus c equals ax squared plus bx. Our next step is then to factor out this a. Now, this is a little strange here because factoring out an a involves me having b over a. So if I'm going to multiply this back in, a times b over a would give me just the b. My magic number is then I take this, what's here, and it's now b over a instead of just b, and I divide that by 2. Well, dividing b over a by 2 is like dividing by 2 over 1, which is multiplying by 1/2, so that's b over 2a. I then have to do b over 2a squared. Since I've added that to this side, I must to the other side add, let's put it in blue actually. Put my magic number in blue here. B over 2a. So when I square that, that's all b over, I'm squaring all of these, b squared over 4a squared. So I've squared the 2 as well. Then to this side, I have to multiply it by a, which a times b squared over 4a squared will cancel the squared here. I cancel 1a from each. So I'm adding b squared over 4a. Oh, when I'm solving this, the process of solving, in place of y, I have a 0 because I'm trying to have where this equals 0. So for the quadratic formula, y must be 0. So I've substituted 0 in for these y's. And now I proceed with completing the square. This side always factors into the b over 2a. So whatever that number, the square root of that magic number, or this divided by 2. Now on this side, I'm going to find a common denominator. I've got negative c plus b squared over 4a. So common denominator is going to be over 4a. So I'm going to multiply the c by 4a over 4a. 4a divided by 4a is 1. But when I multiply, I have a common denominator and I can combine them. So now I need to move the a to the other side. So I divide by a. Dividing by a is the same as multiplying by 1 over a. And again, I'm doing it to both sides, so this keeps it equal. I'm also going to swap the order of these two because I like my negative sign in the middle. Four a times a is 4a squared. So now if I'm trying to isolate x, I'm trying to solve for x, so that means isolate. The next thing I need to get rid of is the square squared of both sides. So I'm going to take the square root of both sides. Now, like if 5 squared and negative 5 squared both equal 25. So if I have x squared equals 25, when I square root, I must add a plus or minus to indicate, this is called plus or minus. It indicates that I have both a positive case and a negative case for the square root. Now, when I'm simplifying this, anytime I simplify a square root, I don't know if you guys have done this before, but when I have a square root of a fraction, I can take the square root of both parts separately. The plus or minus for the fraction, a negative can be any place in a fraction because a negative over a negative makes a positive. So if the negative is on top, it's negative. If the negative is on bottom, it's one negative is a negative. Or if the negative is in front of the fraction, it's a negative. So the plus or minus I just put on top, and I split the square root to top and bottom. The numerator, I cannot simplify that square root. Yes, I could square root b squared, but the minus has to come before I take the square root. And so I can't divide that up. The denominator, however, the square root of 4a squared, there's no pluses or minuses in here at all. So I can just square root both parts. The minus here means I have to simplify the inside before I could square root, and I can't simplify that. So my right side of the equation hasn't changed. Now to get x by itself, I'm just going to subtract this whole term b minus 2a. Giving me here, I'm out of room. Well, these, oops, being a common denominator, so both of these are over 2a, meaning I can put this together as a single fraction. And hey, that is my quadratic formula. Okay, I have another video showing you how to use the quadratic formula.